Today, I'll be discussing this topic, recurrent neural networks, in this video. Now, let's start with what exactly is recurrent neural networks. See, whenever we have to process sequential data, we have to use RNN. Now, what exactly is sequential data? Can I say text? Text is nothing but a sequential data. If I say, how's the weather today? So, how is the and weather make sense, no? It's a kind of a sequence. Similarly, I can say that audio is also a kind of sequential data. Yes, any audio clip. Similarly, alphabets and numbers. Yes, A, B, C, D, and so on. Movement of any person is also sequential data. So whenever we have to process sequential data, we have to use RNN. Now, how RNN is different from feed-forward networks? See, this is our feed-forward network, where we have an input layer, hidden layer, and an output layer. If I feed in a picture of a dog, if I feed in the picture of a dog, then what will I get? I'll get a dog. And if I feed in a picture of an elephant, I'll get an elephant. See, in feed-forward networks, my outputs are not connected. My outputs are independent of each other. While in the case of sequential data, my output is interconnected. So whenever we have to process sequential data, we should always use RNN instead of feed-forward networks. See, this is the structure of RNN. Okay, where, see, what is happening in this structure? See, the question is, how's the weather today? If I say only how does not make any sense. Weather does not make any sense. If I combine all the words together, that makes sense. How is the weather today? So what we do is, first of all, I'll feed how. And then the output of how, that is the output of the previous timestamp, is being fed into is now. Okay, and then the output of is being fed into the, and then the weather, and then today, and that question mark. With the help of this, we can actually find out the answer of this. Okay, I'll give you an example of this again. Once again, see, this is the example. What time is it? And a question mark. See, what does not make any sense? Time also does not make any sense. But if I connect all these words together, what time is it? This makes sense. So this is kind of a sequential data, and this is how RNN process the sequential data. The output of what is being connected to time, and the output of time is being connected to is, and the output of is being connected to it, and then this. Okay, so this is RNN, and this is how RNN process sequential data. Now let's look at the applications of RNN, where we can use RNN. See, the RNN can be used in these three specific applications. Obviously, we can use RNN in multimode applications also. See, these are the three applications. First is speech recognition, language translation. If you have to predict the next word, I guess all of you must have used all these applications somewhere, some around. If you're using a mobile phone, then definitely you must be using all these three applications for sure. Now, let's look at the limitations of RNN. What are the limitations of RNN? I'll give you an example. See, what's written over here is, I grew up in Spain. Okay, I grew up in Spain. I've been working in Indonesia for past 5 years. Earlier, I was working with the United Nations as an ambassador of Timor-Leste. I speak what? I speak what? This is the question. Okay, if I give this question to you, you can easily say I speak Spanish because I grew up in Spain. Because I grew up in Spain, I speak Spanish for sure. But what is happening in RNN is this thing. See, the limitation of RNN. Actually, the limitation of RNN, that RNN has got short memory. See, what? The effect of what is here 100%. it has reduced to 50%, half here. The effect of what is now only 25%, and then half again 12.5%, and here the effect of 6.25%. So it is decreasing exponentially. Okay, the effect of what in this sentence, in this sequential data is decreasing exponentially as this sentence is going forward. Okay, now, so the effect of Spain here, the effect of Spain will be like nothing here, no? Now my RNN will not remember anything about Spain because the effect of Spain is very, very less now. So this is the limitations of RNN, that RNN has got short memory. It has a problem of short memory. It cannot memorize everything. It has a problem of short memory. Just like here. Just like here. As you can see here, the effect of what here and the effect of what here is very, very less. What if, see, the effect of what and time is very less. If I just remove what and time from this sentence, can you answer this question now? No, we cannot answer this question, is it? It does not make any sense. Okay, so this is the limitation of RNN. And there is one more limitation of RNN. We'll discuss that. See, the next limitation of RNN is the vanishing gradient. See, this is our feed-forward network, input layer, hidden layers, output layer, yes? And how does backprop works? Backprop works from output to hidden. We have to initialize the weights and we have to keep on updating the weights so that our error has to be as minimum as possible. So this is the work of backpropagation with the help of gradient. Now, what happens is, see the gradient here and the gradient here, the effect of this gradient at the output layer will have a direct effect on this gradient. And the effect of this gradient will have a direct effect on this gradient. So we can say that gradient keeps on decreasing exponentially as it goes from output layer to input layer. So it decreases exponentially. So if my number of hidden layers are very, very high, okay, if number of neurons are very high, number of layers are high, then there will be a point when there is not any learning in our whole network. I'll give an example on this. See, new weight. This is the formula to change the weight. New weight is weight minus learning rate into gradient. See, if my gradient is very, very, very less, what will happen here? See, my weight is 4.1 minus 0.0001 will give you this weight. So actually you can see that 4.1 and 4.0999 is almost similar. So there is my model, my total network is not learning anything. We can see that. So this is the problem of vanishing gradient which happens in RNN. This is the reason why RNN has a problem of short memory. Now, the range of RNN is limited. The range of RNN is limited and it has a problem of short memory. Now, what methods we can use to increase the range? There are two methods that we can use, that is LSTM. One is LSTM and the second one is transformer. See, the range of LSTM is medium. Basically, we can do almost 90% of the applications using LSTM. And the range of transformer is almost infinite. You can do almost anything with the help of transformer, but yes, transformer, for to be able to process transformer, you need computational power. So it's better to use LSTM where we can use LSTM. But if you have to solve any problem, you can use transformer and you can solve any problem. Now this is structure of RNN. As we have already discussed the structure, see, the use of 10H, I'll just tell you one thing here. The use of 10H here is to normalize our data set. Now let's look at the normalization thing. See, earlier I told you we are feeding into the network only the words, that how is the weather today, what time is it. See, my model does not understand any text. We have to first of all convert that model into vector form. Okay, vector form is like this. It contains of number. Okay, it contains of number. It could be either 5, 0.1, 0.2. Okay, now if I multiply 5 into 5 into 5 into 5, it will overshoot, no? So to overcome this problem, we need to normalize our data set, and with the help of hyperbolic tan function, that is tan h function, we can normalize our data set as the range of tan h function belongs to -1 to +1. Okay, it will convert all the values, whether the value is in 125,000 something, whether the value is in between zero point 0.1, whether the value is 100 or 200 or anything. It will just convert all the values in between -1 to 1, so that it is easier to process the data. Okay, so this is the structure of RN. Now in the next video we'll be discussing about LSTM and how to overcome the problem of short memory. Okay, thank you.